Okay, so this is still the unit circle, but I'm going to talk about the trigonometric ratios within the unit circle. This is going to be a 45-degree angle, reference angle. So that means that the coordinates to this point are the square root of 2 over 2 and the square root of 2 over 2. Now, you might want to have your calculator with you when we're working on this. I'm going to ask you questions. How do I calculate the sine of 45 degrees? Yes, you're going to tell me, Mr. Cook, I'm going to open it. Why did that shrink? Oh, this didn't show up. Never mind. I just kicked the microphone. Now I'm going to turn it on. Okay. So, of course, I'm going to make sure that I'm in degree mode. Type in sine 45. I almost always close my parentheses, except I can't see them now. Okay. Sine of 45 degrees, 0.7071. Okay. Now remember, in class I said the sine of 45 degrees is going to be some ratio, and it's always going to be the same ratio. It's opposite over hypotenuse, but in this case the length of the opposite side is what? Well, magically on the unit circle it's the square root of 2 over 2, and the hypotenuse is 1. So it turns out if we're in the unit circle, the sine of 45 degrees is equal to y, or excuse me, yeah, equal to y. Ooh, I drew this underneath the wrong one. This really goes over here. It's really the y, because opposite the 45 degrees is this length, which is equal to the y value for this point. If I ask for the cosine of 45 degrees, it is going to be the same value, this 0.707 or square root of 2 over 2, because it's an isosceles right triangle. But it is going to be equal to the x value, this value, because that's the adjacent leg to this 45. Then if I'm asking about tangent of 45 degrees, it's going to be equal to the opposite over adjacent, which is going to be y over x, which in this case is 1. But let's apply this to the 30, 60, 90 and see what happens. What are these coordinates? Remember, this is the long one, and this is the short one. Or you could have the square root of 1 over 2. The x is the long, y is the short. Y, x. So the sine of 30 degrees is equal to y, which in this case is 1/2. Does that work? Sine of 30. It's not really putting my button clicks here. Oops, magically, 0.5. So it works. The sine, oops, I want to go to cosine. The cosine of 30 which is degrees. Radical 3 over 2. And it's going to be radical 3 over 2 every time. It's the length of this in the unit circle, if that's 1. What's tangent? It's going to be opposite over adjacent. It's 1/2 over radical 3 over 2, which means it's going to be guys probably need to eyeball that a little bit. The whole when dividing fractions, don't ask why. I flip the second one and then multiply. The 2's equal 1. I get 1 over the square root of 3. And then when I simplify, multiply this fraction by the square root of 3 over 3 to get rid of the radical in the numerator. So these are the kinds of things we're going to be asking you to do. All right, I have a couple example problems from the book, but you get the idea. You're in the unit circle, and I'm going to ask you to find the cosine of negative 180 degrees. Remember, if I have an angle in standard position, 180 degree angle is a negative 180 degree angle is this one. What were the coordinates for this point? Negative x. Excuse me, negative x and y, but y is equal to 0, and the negative x is negative 1. And what was cosine? Cosine is the x length. So therefore, cosine of negative 180 is equal to negative 1. What if I asked you for the secant of 90? The secant of 90 degrees is equal to what, using the unit circle? Well, where's 90 degrees? A 90 degree angle in standard position is here. And so what is that? The coordinates of that point, coordinates of that point is 0, 1. And remember, what is secant trying to do too many things at once. 90 degrees. And so, cosine of 90 degrees. So what is the cosine of 90 degrees? Well, cosine, remember, is the x value. And what is the x value here? The x value for this angle is 0. But here's this problem. I believe you addressed it in Algebra 2. If the cosine of 90 is 0, and I have 0 in the denominator, it should be telling you that the secant of 90 degrees is undefined. Undefined. Oh, I don't want to do that. Okay, a couple more examples. These I'll probably pause, tell you to pause, and then I'll just give you the answers. So let's look at the unit circle again. And an angle that's 135 degrees in the standard position. So the question you should be thinking about is, what is the reference angle of that angle? The reference angle is this angle. I know we haven't talked about it much, but we did cover it. Reference angle is 45 degrees. So what should that be telling you? I'm hoping it's going to tell you that over here, this point has coordinates negative radical 2 over 2 and radical 2 over 2 in the y direction. So now I'm going to ask you, what is the sine of 135? What is the cosine of 135? What is the tangent of 135? What is the cosecant of 135? Oops. What is the secant of 135? And what is the cotangent of 135? So please hit pause now, do all that work, figure that out. I'm going to poke the answers in here for you shortly. Those are the answers. Up here in this area, I tried to show you the simplification. Remember, cosecant, secant, oops, and cotangent are the inverses of the trigonometric ratios of functions I have to their left. So all I did was invert this. I inverted this Why the heck is it? I keep grabbing things. I inverted this to get this, which gave me this, and then I had to simplify it to this square root of 2. If you notice when I was building this out, I almost forgot this negative sign, which is a problem if I left it that way, but this is the negative square root of 2, and this is negative 1 as well. Okay? So there are 2 more example problems I'd love to give you. I'm going to hopefully do those tomorrow, but I'm going to try to get this up tonight before I go to bed so you have something to get going on. All right? Good luck, folks. Have a good weekend. Make your choices.